Welcome everyone. This is the part 4 of our series where we are trying to understand the graph databases. Okay, so in this video we are discussing about the Neo4j, how to set up, how to write query, and how to push the data, and how do we visualize the query responses using Neo4j database. Okay, so this is the content, and let's get started. Neo4j basically is again one of the example of graph database. Okay, here the emphasis is given to the how we can store the data, like the relationship between the data will be stored. Okay, and what are the properties of every chunk of data we can store. All those things we are going to store here. Okay, and here the language what we use is Cypher Query language inspired by the SQL. Okay, yeah. And the best part over here is Neo4j gives very strong visualization facility even on the cloud as well. Our cloud instance you can do so. Okay, so yeah, what we are going to do. Okay, let's take a instance over there in the our Neo4j instance we're going to create, and then we'll try to push the data by using Python API. Okay, and then we'll try to visualize the query outcome, how the results are actually visible. Okay, those things we're going to see. Okay, and yeah, I think this is Cypher Query language, like we discussed, one of the simpler and intuitive query language used to interact with the Neo4j database. Okay, and yeah, let's see some examples. Okay, how we can read, write, and delete the things here. Some of the example query syntaxes are as follows. Okay, if you want to create something on the database, okay, so say you want to create a node. Okay, so the simple example is here. Okay, you can use the command create. Okay, create basically create one node over there. Okay, here for example, okay, person is a node. Okay, and we are giving one alias name to the person as p1. Okay, and person has properties called name is Alice. Okay, and second property is age, which is 30. Okay, and then we are creating another node name as person. Okay, this time the alias to this is p2. Okay, so that we can use this p1 and p2 in the next coming commands if required. Okay, so p2 is another alias to the another type of node, which is person, and it has separate kind of attributes called name, which is Bob, age, which is different as before. Okay, which is here in this case 25. Okay, we created. Okay, now we are trying to make connection between them. Okay, so now we don't have to write person, name, and so on. We can use the alias what we given before. Okay, so for example p1. Okay, and here p2. Okay, in between them we are writing a kind of relation by using a square bracket here in order to represent the relationship. Okay, so you see here knows is a kind of relationship. Person 1 knows person 2. Okay, so again relationship you can have further properties saying since 2018. Okay, so it's saying like this: Alice knows Bob. Okay, since 2018. Okay, p1 knows p2 since 2018. This is how we can say, and it's an arrow. See, from here it starts and heading to p2. Okay, p1 it is starting and heading to p2. This is how we can create two nodes. Okay, give a alias name p1 p2. It can be any other alias name. Okay, it's not it's not like syntax. Okay, you can give any other name. Okay, for example I can give n1 n2 or anything else. Okay, or i1 i2, up to you. Okay, so it's a user specific. Okay, it's up to you, you can define. Okay, and here in the other side, okay, we are writing the other query. The second syntax is match and return. Okay, this match and return basically is used to filter the data or filter the graph. Okay, whatever requirement we are giving or query we are giving. Okay, for example, okay, p is nothing but person. Okay, filter all the places where person p, okay, knows, okay, person, another person, okay, and the condition we are writing, the alias p, okay, should be Alice, okay, and it means what, okay, I want all the places where Alice knows another person, or I want all the friend list of Alice, okay. P or P1 person knows another person who should be a friend, okay. So here, if you see here, we given name as P1 P2, here we given P, and here instead of P2 we given friend, okay. It can be something else, there is no concern, okay, but the type of node is person, okay. So where P dot name is same as Alice, so Alice should be the name of a person, okay. The property of the node should be Alice, the name should be Alice, okay, and then whatever the result we are getting, out of which return only the P dot name, which is Alice, okay, and friend dot name, okay, Alice, and its friend list you will return as a response, okay. In the same way, you can also delete some of the things, okay. For example, match places where P person, okay, should be name as Bob, okay, and detach it and delete the P, okay. Here we are returning the P, okay. Whatever the result you are getting, just detach and make delete the all the places where Bob exists, okay. So this is how it will delete, okay. This is the third command, okay. In the same way, we have another command which is called merge, okay. It basically create the node if it is not exist, okay. If it is exist, it will try to match it, okay. So it says movie, okay. Again the alias name is movie, the node name is movie, okay, and the property of this node is title, okay, which is the matrix, okay. So if it is not available, if we are creating first time, so it says on create, set the movie release date as 1999, okay. It's the first one, okay, and what we are returning, okay, the return is movie name, okay. So movie we are returning, which is the matrix, okay. This is how the basic commands of Cypher query we can do, okay. Let's see this in as an example in the notebook, okay. Let's go. Here I am back to Neo4j Aura cloud instance, okay, wherein first when you are coming first time, you have to make a login, okay. Once you log in, okay, it with your ID or any ID, I use my Gmail ID to log in for experiment purpose, okay. So it will offer you multiple options, okay. Like premium, you can get a paid version or business class as well, okay. But for our discussion, I created a Sandbox one, a free version for our explanation purpose, okay. Once you log in, come back to instance location, okay, and inside instance you can go for create instance, okay, okay, and then you can choose which you like, okay. I selected a free version, okay, and then click on create, okay. It will create it will create based upon the options. I use the default one, okay. Once it is created, it will pop up a password, okay. Just note down the password and keep it. It will also give you an option to download your credentials, okay. You can take it and store it somewhere so that we can use it for our experimentation, okay. So that's how it should be, okay. And then let me go back. Once you create, yeah, let me cancel since I already created, okay. So after you create, it will come like here instance 1, okay, which is running, okay, and in this we have 0 nodes and 0 relationships, okay. And if I click here, you have options here. I am going for query, okay, no connection, yeah, connection done, okay. It's loading. Let's see. I think it's empty. Yes, we all are empty. We did not do anything so far. Great, okay. Now let's go back to our let's go to a notebook, okay. This is my Google Colab notebook, okay, wherein I'm trying to, okay, explain you how to connect and how to use it, okay. Let me zoom a bit. Hope it is visible. Yeah. Great. Let me zoom. Yeah, so just for experiment I just try to use Google Colab here. So I am running. Okay, for our experimentation I am using LangChain and Neo4j installation. Okay, the pipelines are used here. Okay, I installed it. Okay, after that okay yeah, so just import the required things like graph database. I use it here. Okay, so you have to replace your my credentials with your credentials. Okay, so for example after that just write a graph database dot driver. Okay, this is used to connect to the database. Okay, so provide your URI. Okay, username. Okay, and password. These three things you will get it. Okay, when you create it. Okay, let me show for example. If you go to instances again, if you create over here, okay, it will provide you all these three information. Just note down and keep it in the environment variable if you like. Okay, or you can use it just for experiment. Okay, so both options are available. You can do so. Okay, so just connect to the graph database. Okay, which is a driver throw. Okay, and then this is the connection link, or you can say client here. Okay, so you can give a better name if you like. So I given as graph underscore db also you can provide. Okay, so connection is done. Okay, that means yeah, it's done. Okay, and then we also need a LangChain community. Okay, just installing all the required packages. Is it done? Yeah, done. Okay, great. Let's see the connectivity. Okay, graph dot verify connectivity. Yes, we are connected. Okay, perfect. Now there is a time to write a query here. So before going to the query, okay, just come to the execution step here. Okay, we have the same graph. Okay, we have an option. Okay, called execute query. Okay, here basically we need to provide the query in terms of a string. Okay, since it's a Python interface, in order to connect and write the query, okay, the query should be in a specific format like a string. Okay, that's why we are making a complete string here. Okay, giving name as Cypher query. Okay, and then we are trying to pass it to the execute query command of graph, Neo4j graph. Okay, and yeah, so then provide the other stuff like database name, which is again Neo4j. It will be provided to you in the that text when at the time of creation of instance you will get this name. Okay, and routine we are trying to write it. Okay, that's where it's w. Okay, so let's see what is the query. Okay, so now I use some context related to Marie Curie and Perry Curie. Okay, these are the scientists. Okay, so they did work on radioactivity in physics and chemistry and got the Nobel Prize. Okay, so let's write some, and they married to each other as well. Okay, so let's see how to do it. Okay, so I am using here the merge command. Okay, in order to create it. Okay, you can use create also if you like. Okay, so alias name I am using MC for Marie Curie and PC for Perry Curie. Okay, and the node name is person. Okay, person 1 which is MC, person 2 which is PC. Okay, and the attributes are Marie Curie. Okay, and name and born date. Okay, and person 2 again Perry Curie name and born date we are providing. Okay, we created two nodes here. Okay, with some attributes. Okay, let's create some more nodes. Okay, like name is award. Okay, instead of person this time it's award node name. Okay, property is Nobel Prize. Okay, alias name as NP. In the same way, institution name as University of Paris and scientific field SR. Okay, you can change the names if you like. Okay, this is just for convenient I written. Okay, here it's a radioactivity, another node for physics and for chemistry. Okay, so we created multiple nodes. Okay, after that let's try to make some relationship between them. Okay, so MC means Marie Curie. Okay, conducted research on, it's a relationship. Okay, on what? Radioactivity. Okay, SR. Okay, conducted research on radioactivity. Okay, MC conducted on research on radioactivity, and MC won prize in, okay, physics, okay, SP scientific field physics, okay, and also MC won prize in SC, okay, in chemistry also, okay. So these are the two multiple awards, award recognition Marie Curie got, okay. And also some more, okay, let's see, okay. Here in this example line I am providing the attributes at the relationship level also, okay, we can do so, okay. Marie Curie won, okay, what, okay, Nobel Prize, okay, year 1903, okay. This is the information at the relationship we are providing, okay. Number of count is 1, this only 1, okay, and role is first woman, okay. You can write any attributes over here at the relationship, so that you can query, okay. So name a person who won the Nobel Prize, okay, in the year 1903, you can tell. This can be a kind of query you can do, okay. And also some more relationships, like Marie Curie won count number as 2 this time, okay, and role is first person to win twice, okay, Nobel Prize, okay, okay. In the same way one more we written, okay, the relationship, okay, and then some more between the two persons, two Nobel Prize winners, okay. So Marie Curie married to Marie Curie, so we can say MC married to PC, okay, and MC co won award Nobel Prize, and PC co won award Nobel Prize, okay, they win together, okay. That's the thing. So this is our query we written, which is here, we converted to a text format, and we try to execute this, okay. After execution, okay, we are trying to display how many nodes, how many what's the total summary, and how many relationship and properties we are having. We are trying to run and see. Yeah, let's run it. Yeah, so I think I run before as well. So yeah, so when you see now the number of nodes are 7, okay, relationships are 9, and the properties are 16, okay. Now let's go to our database here, okay. So you can see now it's changed to 7 and 9, okay. Let's connect query, let's wait for load. Yes, let it to get load. Perfect. Now you can see these things already came now, okay. Now if you want to see all the available nodes, okay, just click on this star, okay. So let me zoom it, tick tick tick. Yes, so here it's a node physics, here node Nobel Prize, node Marie Curie, okay, and so on, okay. This you can see, okay, and yeah, perfect. And there are multiple options. If you like, you can zoom and review your things will be available, okay. And one more thing, just try to notice here, I click on the star button, so it created a query for myself, okay. So the query is match, okay, okay. It says match all the nodes, okay, which are available, and return all n, okay, and make a limit of 25, okay. This is a graph visualization. You can even keep point, and you can rotate, and you can make some further changes here. This is a great visualization option provided by the Neo4j, okay. And in the same way you can see the details in the table format, okay, or in the raw format. Yeah, these are the options available, okay. And if you like to further see the relationships among the different nodes, okay, let me again go this side, zoom it a bit, hope it's visible, okay. So here you can see Marie Curie, okay, and Marie Curie, okay. The relationship between them is married to, okay. And in the same way Marie Curie won the prize in chemistry, won the prize in physics, okay, and again conducted research on radioactivity, and so on. So this complete graph you can visualize, and you can make some experiment, okay. And again you see how the query is being written, okay. After I click, okay, here it says match. Okay, what is match? All the nodes with all other nodes with any kind of relationship. Okay, and we are all giving this complete stuff. Okay, and giving equal to, okay, equal to this complete equal to p we are telling. Okay, every node connected to every node. Okay, return everything with respect and all the relationships. It can be any relationship. Take everything and put into p and return p and make a limit of 25. I don't want to see everything since our number of nodes graphs are limited, so we got everything to be visualized. It's a small graph, yeah, for our experimentation. Yeah, here you can see bond date, everything is available. Okay, if you click on bond date, okay, oh, it's, yeah, let me minimize it. Yeah, so like it can say like node this node 1. Okay, and this is a node having this information. Okay, in the raw format also you can see. Okay, so these are the details, and again it creates all the node details query according to your requirement. Okay, and yeah, these are the some further options wanted to show you. It will show you the history of commands what you have print. Okay, and also some more information. Here you can see there are other optional kind of commands exist. Okay, for example, we have seen create, merge, delete. Okay, you can also have remove also. You can make some experiment with that. Okay, like we have seen return, we've seen match. Okay, you can also see union or where clause. Okay, you can try to use. Okay, like for example here match n we have said. Okay, where, okay, n dot born is not null. Okay, so this is how you can write a query. Okay, then return whatever you are getting. Okay, so you can do all these experiments. These are the starting point, I would say, where you can start writing and analyzing. Okay, and some more kind of queries you can see here. We just did, the history is available here. Okay, so this is about, see, for example here one more query. Okay, what we are telling here. Okay, match p is a node. Okay, person. Okay, all the who won the award. Okay, who won the award and where p should be married. Okay, return p. Okay, you can say like that. Okay, it's very intuitive and user friendly queries. Okay, you can use it. And one more place I just want to highlight here. Okay, suppose if you want to write queries and if you are new and if you like to make some queries by yourself, and if you are not fully aware how to write the syntax, okay, don't worry, here there is one more AI generative AI based query generation is also available. You just write your text, what kind of query you want to do. Okay, for example, I would say you can say query for okay, person who married. Okay, who is married. Okay, ठीक है, let's see. Okay, so it will generate and give query like this. Okay, so it generate like saying match p is a person married to another person and return the name of the person. Okay, so you can click here, let's see it will work or not. Yes, it works. It is called Marie Curie. Okay, which which is true in our case. Okay, so in the same way you can auto generate the queries by using this generate query example as well. Okay, if you are a beginner, this is a good starting point for you. Okay, you can do this. Okay, that's it in this video, and in the next video we'll going to see in a bit advanced form. Okay, wherein we'll try to use the LLM models in order to write the query in the natural language, convert to Cypher query and return the response, and the response again convert to natural language and give it back. Okay, we'll see all these things in the second video. Thanks for your time and have a nice day till then. See you in the next video. Bye.